Hi, this is Kat Fohl, Math 1203, Project 3 for Unit 12. For this project, on page 609 of our textbook, I've chosen problem number 10. It is z equals 5x minus 2y with the constraints of 0 is less than or equal to x, which is less than or equal to 5. 0 is less than or equal to y, which is less than or equal to 3. And x plus y is greater than or equal to 2. I have it written right here. The first thing we are to do is to graph the system. Then we will find the value of the objective function at each corner. And then we will use the values in the part B to determine the maximum value of the objective function. So, the first thing we will do is rewrite this first constraint. This first constraint can also be written as x equals 0 and x equals 5. So to graph that, we know that it's going to be in this upper right quadrant. So the first point is x equals 0. So right here, we will graph x equals 0. And that point is right here. And we're going to draw a solid line to indicate that x equals 0. Our next point is x equals 5. 5 is right here, so we will draw a line at x equals 5. So we know that this inequality is going to happen in this area right here. So we'll just go on and shade in this area because it is constrained to the area between x equals 0 and x equals 5. Now, we need to graph x plus y is greater than or equal to 2. The way we do that is to first find the x-intercept. To find the x-intercept, we will put y equal to 0 in this equation. And then we will set the problem equal to 2. So x plus 0 equals 2 means that x is equal to 2. So we will have a point at 2 with the 0 on y. Now we need to find the y-intercept. To find the y-intercept where it crosses the y-axis, we will put a 0 in the x place and set the problem equal to 2. So this will mean that y is also equal to 2. So we know that there will be a line that passes through 0, 2. And we will plot the point 0, 2. And then we will draw a line between these 2 points because this is the same equation. So we are going to graph 2, 0, 2, 0, and we will also graph 0, 2. And this is one line, so we will draw a line through those 2 points. There we go. So now we know that this graph will happen above these 2 points. The next thing we need to do is graph the other constraint. So the other way to write this is y equals 0 and y equals 3. So we will draw a line where y equals 0, which is this line right here. And then draw a line where y equals 3. So we will draw a line right through here. So we have 0, 3. And the lines intersect here at 5, 3. And then we have a dot here at 5, 0. So now we have 5 places where this system of inequalities meet. So the graph of this group of inequalities is in this darkened area right through here. This is the graph of z equals 5x minus 2y with the constraints of x, the constraints of y, and the other line. Now that we have this problem graphed, we need to find the value of the objective function at each corner. So the way we're going to do that is take each point and substitute it for our original problem. So first we will take the point 2.0 and then 0.2 and then 0.3, 5 and 3, and then 5 and 0. And we will plug them into the original problem. So when we do that, we will have 5 times 2, which is 10, minus 2 times 0, which is 0. And that will give us 10, because 10 plus 0 is 10. Now, we plug in the next set of numbers. So we would have 5 times 0, which is 0, minus 2 times 2, which is 4, and 0 minus 4 gives us negative 4. Plugging in the next set, we have 5 times 0, which is 0, and 2 times 3, which is 6. 0 minus 6 gives us negative 6. On to the next set, 5 times 5 minus 2 times 3. So we have 25 minus 6, and that will give us 19. Then we have plugging in 5 times 5 minus 2 times 0, 25, minus 0 gives us 25. So, we have found the value of the objective function at each corner. The value at 2, 0 is 10. The value at 0, 2 is negative 4. The value at 0, 3 is negative 6. The value at 5, 3 is 19. And the value at 5, 0 is 25. So the third part is use these values from B to determine the maximum value and the values of X and Y which the maximum occurs. So we can look at this chart and see that the maximum value is 25, and this occurs at 5, 0 on this graph. So the problem is now complete.